So we have this function f of x equals all that stuff right there, and right down here is the general form. It's telling us to find a whole bunch of different things. So the first is the amplitude, which is the a. We just match this up, and that's going to be pretty obvious. That's just going to be 2. The period is going to be 2 pi over the absolute value here of b. In this case, the absolute value of b is the number right there in front of the x, which is going to be pi over 4. So we're going to have 2 pi divided by pi over 4. And if kind of missing out on the old algebra skills, it's the same thing as writing 2 pi. We can use this obulus symbol, pi over 4. We can divide any number by 1 without changing it. So to multiply, to divide two fractions, we take the second fraction, flip it over, and then multiply straight across. So note here that the pi's are going to cancel each other out. And 2 times 4 is 8. 8 over 1 is just going to be 8. So that is going to be our period. The midline is going to be equal to, y is going to equal whatever this thing is out here. In this case, it's a positive 4. If that was a negative 4, we would actually write a negative 4. That's a positive 4, so we're just going to have a positive 4 there. Now, the vertical translation is also right here. In this case, when it's outside of it, it's going to do exactly what you think, up or down, exactly what you would think. So this is going to go up 4. So let's say we had, for example, y equals x squared. If we wanted to raise it up 5 units, we would just put a plus 5 at the end. When it's inside of the parentheses attached to like the little operator there, it's going to be the opposite of what you would think. So if we had something like x plus 6 squared here in parentheses, this would make it go left 6, kind of the opposite of what you're expecting. If it was y equals x minus 4 to the third power, this would do the opposite of what you think and make it go right 4. So for the problem in what we're actually doing, this is x minus 3. The opposite, you kind of think it's going to go left, but it's really going to go right 3 because it's part of the operation of sine. We're going to use the unit circle as a reminder to find the maximum for the sine. It's going to take place at pi over 2. That's the highest value of y, which is the sine, which is going to be 1. To find out when this is going to occur, we're going to take the pi over 4 times x minus 3, and we're going to set it equal to pi over 2. So I'm going to multiply both sides by 4 over pi to cancel that out. And that's going to leave us with x minus 3 equals, the pi's cancel out, and 4 divided by 2 is 2. And of course, we just add 2 to both sides, and we're going to get x equals 5. So this is where the maximum is going to occur. The y value for it, using this equation, we know that the sine right here, what I just circled there in a light green, is going to equal 1. So it's really going to be 2 times 1 plus 4, and that's going to be 6. So that's going to be our maximum. So the maximum point then is 5, 6. And we're going to do the same idea to find the minimum. We know the minimum for sine is going to occur at the point 3 pi over 2. So we need to solve pi over 4 times x minus 3 equals 3 pi over 2. So again, we're going to multiply both sides by the reciprocal, which is 4 over pi. And that's going to leave us with x minus 3. The pi's are going to cancel each other out. So it's really going to be 3 times 4 over 12. 12 over 2 is 6. So x minus 3 equals 6. Add 3 to both sides, and that's going to give us an x value of positive 9 for the minimum. Now right here, that spot there in the purple box, all that's going to equal -1. So it's really going to be, y value is going to be 2 times -1 plus 4. 2 times -1 is -2. And negative 2 plus 4 is 2. So our point for the minimum is going to be 9, comma 2. So if you have any kind of questions, go ahead and email me.